Here's what happens when we multiply binomial factors. The x squared comes from x times x. The 4 comes from adding 7 and negative 3. And the negative 21 comes from multiplying 7 and negative 3. We can see that factoring and multiplying are related. Now, to factor this expression, we must go backwards in our reasoning. For starters, we clearly know where the x squared comes from, so we can put the x's in place. Rule 3 tells us to ask, are there factors of negative 21 that add up to positive 4? The answer is yes. Negative 3 and 7. Now we know what else goes in the parentheses. Even very scary-looking expressions can be factored. Always try Rule 1 first. Remember, when the first term is negative, we can factor out the negative. We can factor out negative 2x cubed y cubed. We'll try Rule 3. We know x goes in the first spot in both terms. Now we ask, are there factors of negative 14 that add up to negative 5? The answer is yes, negative 7 and 2. Now we know that the remaining factors are the quantity x minus 7 and the quantity x plus 2. It's easy to see why Rule 3 is so useful. It's often helpful to notice patterns in math. For instance, this expression looks a lot like x squared minus 2x minus 24. They can both be factored using Rule 3. Ask, are there factors of negative 24 that add up to negative 2? The answer is yes, negative 6 and positive 4. The only difference is you need to put a y with both the negative 6 and the positive 4. When we check by using the FOIL method, we see that last times last gives us negative 24y squared. You can use Rule 3 even if your first term isn't x squared. As long as you have 3 terms and the exponent of the first term is twice as big as the exponent of the second term, Rule 3 will work. To get x to the 4th power, we'll need x squared times x squared. Negative 9 and positive 2 are the factors of negative 18 that add together to equal negative 7. So far, so good, but we can't stop factoring yet. Rule 2 works on x squared minus 9. And now we're done.